Hello children, we started our last class, that is lesson, science lesson, force and pressure. Okay, so in this force we are seeing now. Okay, so what is the force? That is a pull or push exerted on an object by one another. Okay, is called a force. Okay, so that is we are giving any force to an object. That object should be moved or is at rest. Both are we are saying it as motion. An object is at rest also a force. Okay, so there also we are mentioning a force there. Okay, it is observing, that is gravitational force is applying on an object. Okay, so while an object is at rest or the object is moving. Okay, both are we are saying it as a force. Okay. So we have types of forces we saw in our last class. Okay, that is we saw the topic first as force. Okay, so what is a force? Okay, a pull or push exerted on an object. Okay, then we saw magnetic force in that. Okay, magnetic force. Okay, so what is the magnetic force? Okay, it is also based on attracting or repulsion of an objects. Okay, repulsion of an objects. Okay, magnetic force means the one thing it should be attracts or it should be repulsions. Okay, based on that, this magnetic force is applying on an objects. The other thing is gravitational force we saw. Okay, gravitational force. Okay, so gravitational force. All the objects it is based on the gravitational force. Now we also walking on the earth. Okay, walking and we are running or we are any work we are doing that is based on the gravitational force. Okay, so if we are lifting any objects, okay, so we are leaving that objects at any cost. Okay, we are leaving. That objects are observed by the gravitational force that should be comes down and it fall on the rest. Okay, so while the mass of an object it moves down fast or it slows. Okay, based on the mass of an object. Okay, so all the objects having a gravitational force. Okay, then we saw the examples also in our last class. Okay, then we move on to a new one, that is net force. Now what does mean by net force? Okay, what does mean by net force? Okay, see, net force means that is the difference between the two forces acting on an object. Okay, so what does mean by net force? The difference between the two forces, acting on an object. So let us take one example. Okay, two children. Okay, they are moving the table from one place to the another place. Okay, two children, they are moving a table. Okay, from one place to another place. This example you are all experienced in our school. Is it right, children? Okay, see, two children, they are moving the table from one place to another place. Okay, let us take this as a table. Okay, so let us take this as a table. They are moving. Okay, they are taking, one child is taking this side and one child is taking from this side. Okay, they are moving. Both the child is moving, a direction is this side. Both the child is moving, a table as direction as this side. Okay, so here the force is acting from one side itself. He is also moving this side only. He is also moving this side only. The force is moving a same side of the tap. both are in the same direction. Okay, so here the forces applied on the object is in the same direction. There is no opposite forces. Okay, in net force we should take the opposite forces. Difference means we want to calculate difference between the opposite forces. Okay, so for that we should take difference. So here the student, a child, he is giving a force to this side and he is moving a child force to this side. Both the childs, they are thinking the table should be moving to that side or this side. They don't know where. So this child is moving the table to this side, so this direction, and this child is moving a table to this direction, opposite directions. Okay, so here the child 1 is giving a force of 7 newtons. So what is the SI unit of force? You know in your last class 7 also. So SI unit of force is Newton. Okay. 7 Newton of force is given by the child 1. Okay. So here the child 2. Okay. Here the force is given by the child 2 is 5 newtons. Okay. So now the force is given by the child 1 is 7 newtons. So the table is moving this side. Okay. The opposite side, the child is giving force 5 newtons. Little bit. Okay. Comparing these two forces. So this child 2 force is given by the child 2 is less than the force is given by the child 1. Okay. So now you should compare these two forces. Okay. The difference between these two forces is 2 newtons. The difference between these two forces is 2 newtons. Is it right? So this is the net force. Okay. Calculated by this force. Here the force is calculated by these two situations. The net force is 2 newtons. Okay. So or otherwise, a child is very strong. Okay. The child 1 is very strong. Okay. So the force is given by the child 1 is 7 newton. Okay. And here in this side, the second child is very weak. Okay. So we are adding one more child here, the child 3. Okay. The two children here, these two children are given the force to the side. Okay. So second child also given 5 newtons and the third child also given 5 newtons. Is it right? Okay. So 5 newtons and 5 newtons force is given from the side. Now you should compare these two forces. Understood? So here the child 1 is giving 7 newton force to this table. Okay. Excuse me. 7 newton force to this table. Now here we are adding these two forces are given by one side of this table now. So here 10 newtons. So comparing these two forces, now we have the net force as 10 minus 7. 10 minus 7. The net force as 3 newtons. The net force has 3 newtons. Understood? So what is a net force? Okay. So this is an example for net force. Are you understood? I thought, are you understood, children? Okay. So what is a net force? Okay. And one more thing I will say, that is the force is having a magnitude, a value. Okay. Without a value, force cannot apply. Okay. So here 7 newton. Okay. 7 newton of force is applied by the child 1 and 5 newton of force is applied by the child 2. Okay. And 5 newton of force is applied by the child 3. Okay. So now we have 7 newtons here. In this side we have 10 newtons. The net force of these two forces having 3 newtons. So from this we can conclude force has magnitude. What is mean by magnitude? Okay. Force has magnitude. Okay. So what is mean by magnitude? What is the having a value. Okay, so value. And we can say that force is moving from this side to this side. Okay, we can say wind is also a force. Wind is also having a force. Wind is moving from left direction to right direction. Okay, for us. Okay, now for us, wind is moving from right direction to left direction, or left direction to right direction. Okay, while moving a wind, we are pushed. Okay, we are pushed by the wind from what is the direction wind is moving, wind is blowing. Okay, from left to right, wind is blowing means we are also pushing by the left to right directions. Okay, so the direction. Okay, a force having a direction also. Okay, we can say force has magnitude and direction. Magnitude and direction. Okay, this comes under one mark question. Force has magnitude and direction. Force has both magnitude and direction. Understood, children? Force has a magnitude and direction. Okay, so this is the exploring forces. Okay, so based on the exploring forces, a child is moving. Okay, children are moving a table from one place to another place. While moving, they are giving forces on the table. Okay, all the children are giving a same side means there is no force. We can have a value. Okay, we can have a magnitude and direction there. Okay, but there is no net force calculation. Okay, because of they are moving in a single direction. If an object is exploring by the opposite forces, okay, so that is one child is giving this side force, opposite force, and another child are giving the opposite force, means we have a net force. Okay, so based on this, so applications of force. What are the applications of force? Okay, a force often affect changes and some objects. Okay, shape of the object also changes. Okay, so that is we are pushing. Okay, I'll say one example. Okay, a spring is fitted under the seat on the bicycle. Okay, on the bicycle we can see a seat is fitted, that is under that is a spring. Okay, that spring system should be elaborating. Okay, so while we are sitting, the spring should be actioning. The action should be there. Okay, so that is push or pull by the spring. Okay, so while we are sitting, the spring should be pushed under. Okay, so under the seat. So there is a forces acting on the object. While we are sitting, the force is acting on the spring. That spring should be pushed. Okay, so here also forces acting by the magnitude, by the value and the direction. Okay, so then this is the first application of force, that is forces acting. Okay, the effect that changes the state of an object. Okay, that is the shape also changes, and one more thing, state of an object. See, application of force. The first thing, let us see state of an object. Okay, state of an object. Okay, what does it mean by state of an object? So while we are taking any bicycle or any vehicle we are taking, that vehicle is at rest first. Okay, that vehicle is at rest. Then we are giving any acceleration, it moves. Okay, depends upon the speed of a vehicle. Okay, so that is based on the speed. Okay, here we are saying it as velocity. Okay, so we are giving any force to the object. Okay, that object is at rest. After we are giving any force, that object is moves. Okay, it is state of an object is differs. It moves. Okay, the object that object of a motion, okay, or at rest or at motion. Then it can change an object's directions, okay. So state of an object means if it is at rest or motion. When force is acting, okay, while force is acting on it, is at rest or is at motion, okay. Then the second one is direction, okay, direction, okay. While we are giving any force, that force, based on that force, an object is moving, okay, the direction is moving, okay. While we are going anywhere, okay, on a vehicle, we are moving in a single direction and we are giving force to the another direction, that vehicle is moving another side, okay, it is object, okay. And we are taking example for table also, that child is moving in a east direction and then they changes and they gave the force on the table as west direction, it moves to the west direction. So direction also changes, okay. And then I told you there is shape of an object, okay, shape of an object, okay. Shape of an object means the screen should be elaborated, okay, that is and then we can take an rubber band, okay, rubber band. So we are elaborating the rubber band, it moves, okay, it elaborates, and we are leaving as it is means it comes to the rest, okay. That is shape of an object also changes, okay. Understood, children? Okay, these are the applications of the force, okay. See once again, what are the applications of the force? So state of an object, okay, the state of an object is differs. So is at rest or is at motion. So while we are giving any force, that it moves to the it should be moves to the motion, okay. Or if the object is at motion, means it comes to the rest, okay. Both are in the state of an object. And we can say one more example. Any machines is at rest. While we are giving electrical force, it should be motion. That is, it is moving, it is working, it is running, okay. We can say that is a force. And any machineries are working or running, that we are switch off the force, okay. We are slowing the force, it comes to the rest. That is state of the object, state of the motion, okay. Then directions, okay. We are giving any force to any direction that moves along the force given us by the direction, okay. Then shape of an object, okay. So we are taking a ball, okay. So volleyball or any other ball, we are giving a force to that ball. That ball should be change the shape of an object, okay. So that is based on this, the applications of force, based on this three applications, okay. Then we move on to the state of a motion, okay. State of a motion. So the state of a motion is based on that is defined as based on the inertia, okay. So while we are taking this talking in this lesson based on the state of the motion and based on the directions also. So here we have to know that is force has a magnitude and as well as the direction. Is it right? So this we can say it as a vector quantity. Vector quantity. You know what is scalar and vector quantity. Scalar means only it has a magnitude. There is no directions. Okay. Okay. That is example distance we can say. Here displacement is both having a vector quantity. That is both magnitude and direction. Here force is also having a magnitude and direction. So force we can say it as a vector quantity. Understood, children? So vector quantity. So here the state of motion, the state of force, it can be based on, we can define it as based on the inertia. Okay, what does it mean by inertia? The tendency of an object, it can be at rest or it can be in motion. Okay. That is based on that force we can talking about here. Okay, understood, children? Then the tendency of an object to resist changes its velocity. are giving any force to the object, it changes its velocity. Okay. So velocity changes means its acceleration also changes. Okay, automatically. Then the object is at rest. So we can say it has zero velocity. Okay, the object is at rest means it has zero velocity. Okay, the state of motion. We are talking about state of motion. State of motion. Okay, that is the object is at rest means zero velocity. Object is at rest. Object is at rest means zero velocity. Zero velocity. Okay, that is in the absence of the unbalanced forces. It will be absence of the any force. Absence of the any force. The object is at rest. Object is at rest means it should be mentioned as zero velocity. Okay, it will change the state of the motion when we are giving any force to the object. Okay, when we are giving any force. Okay, that is force is given to the object. Force is given to the object. Force is given to the object means there is a velocity. Okay, so based on this velocity, the state of motion should be changes. Based on the inertia, the state of the motion should be changes. Okay. So here we have object versus changes in their velocity. So object is at rest means zero velocity, and object is at moving position, that is motion means there is a velocity based on the given force. Okay. So here we know what is the states of motion. States of motion is based on the inertia. What does mean by inertia? The tendency of an object is at rest or is at motion. So that is at rest or is in motion means based on the velocity. Based on the velocity. So velocity we can say it as a scalar, vector quantity. So the velocity also having a both magnitude and direction. Okay. So force is given to the object, that is based on the velocity. So force object is at rest means there is no any force given by us. So we can say it as zero velocity, and force